What's up, everyone? Welcome back to Web3 SQL Weekly number 2. This is a series where I break down a query a week into bite-sized bits, making both the blockchain and SQL concepts more digestible. This week, we're going to be looking at how do you find contracts that have integrated with another contract. If you want to suggest or vote on queries for future weeks, the link is down in the description. Now, let's get into it. So, for this week, this was the winning query. So essentially, we're going to take a look and see for a given contract, and the one inputted here is Seaport, which is Opensea's NFT marketplace, which contracts called Seaport the most, essentially, per week. So we can see, for example, for the week of October 17th, 2022, GemSwap called Seaport essentially 15.5 thousand times. To get a better idea of this, let's go to the dashboard that this query lives in. All right, so that's the quick start analysis dashboard, and Seaport's already in here. So I'm going to scroll down to the protocol integrations. Here's an example of GemSwap calling Seaport, and essentially GemSwap is calling fulfill available advanced orders, and the function being called on GemSwap is batch buy with ETH. Let's look at that further with a transaction hash. Again, Etherscan is not the ideal tool for this. We actually want to go to BlockSec, and I'm going to put in the transaction hash and let it load. And you see here actually that GemSwap is an aggregator marketplace, right? So you can use it to sweep or buy NFTs across a whole series of different marketplaces. We see here that Seaport was called once and X2Y2 was called once, so likely there were 2 NFTs that were bought. And everything over here is just royalties and everything being paid out. So if we look, we can see GemSwap was called here, right, by this address, and they called batch buy with ETH. And then GemSwap calls Seaport at the trace level 02. So you can see, okay, this would be an example of Gem calling Seaport. But something else you have to keep in mind here is there are calls that essentially modify state, and there are calls that just read state, essentially. So, for example, the call here is actually changing the data, right? It's changing who owns the NFT and that's making payments. But you'll also see static calls, and static calls are essentially function calls that don't change the state of anything. You're basically calling a read function on some contract, right? So here, they're calling the pausable zone contract and saying, hey, is the order valid or not? And then that will trigger other logic within the transfer, but this doesn't actually do anything to change the state. This is very important to keep in mind because we will be filtering out function calls that are only reads. We only care about function calls that modify in our case. So without further ado, let's write this query itself. Cool, so I'm going to open a new query. I'm going to switch to the Dune SQL engine. And first thing we want to do is let's look at Ethereum traces, right? So traces is one of the raw tables that every EVM blockchain has. And traces are just the internal transactions within a transaction, right? So it's anytime an ETH is transferred or another contract is called, you have a trace. So let's look at where the transaction hash of the trace is equal to this gem batch buy earlier, right? So I'm just going to put this in here. I don't need quotes because it's just natively a byte array. And let's make this a little faster just by checking for block number equals this. All right, so we have all of the traces. There's 72 traces for this call. And what I'm going to do is I'm going to look at the trace address and I'm going to show the 2 in here. All right, so the first call should be to the gem contract if we're looking at this transaction from earlier. And I can see gem is 0x83cf, 0x83cf is here, and it should be this 0x9a2b function call, 0x9a2b, right? So that's 0, and the trace that we want is where, a seaport is called, right? So that's where this 006 address is called with the 0x87 function signature. All right, so if I look here at this point, which this is the second trace, right? This is seaport being called with this swap. So what do we need to see here? We need to see essentially when is seaport called by some contract, right? So in this case, I want all from traces where, sure, this transaction hash and 2 is equal to the seaport address. So let's filter for this. And we can see here that this is the trace address we were seeing earlier, right? So now let's say I remove this and I say where block time is greater than now minus interval, let's say 1 hour. So what we see here now is all of the times that seaport was called in the last hour or so in different transactions, right? So this is no longer just looking at one transaction. We can see that there are a bunch of different addresses that are calling seaport. But notice most of these trace addresses are null, right? So if this is empty, that means that was like a top level transaction where a wallet made the call. But we don't want to include wallets, right? So we're going to say, and cardinality of trace address is not equal to 0. You could also do a is not null here. And also we want to make sure that we're only looking at successful transactions, right? So let's filter this. And now all of these should be contracts. All right, so just to check this, I'm gonna go to Etherscan, put in this address and see, all right, yeah, this is a contract. I could try another one. It's also a contract, all right. So that's the first step done. The next thing we need is let's get the distinct contracts, right? So now I'm saying, all right, in the last hour, how many distinct contracts called seaport? And here I can see it's 13. Cool, so I know there's 13 contracts, but we do want to keep track of the contracts. So instead, I'm gonna say, give me the distinct number of transaction hashes instead, all right? As let's say times called. And because we're now using an aggregation function, this is the same as if I'd done count distinct transaction hash. These are the same logic. Because of this, I need to add a group by 1. Let's just call this integration type. You can already see that there's some contracts here that have called 14 different times. So the steps left to do are we need to get this by date. So let's do a date trunk and let's say I want the week. So let's do a group by like this. And now let's do 1 month instead. So now I can see, okay, for every given week, how many times was each integration called, right? This is the same address we saw earlier. It was called 3,600 times. If memory serves me, I think this is actually MoonPay. Basically, you can use your credit card to buy NFTs. But let's just do a quick visualization. If I do week and then times called and we group by integration type, and then we stack it, we can see, okay, there's a bunch, right? There's a bunch going on here, but it's not really legible because all of the addresses are in hexadecimal or byte form. So let's make this more legible. Let's do a left join on labels. So labels is one of our spellbook tables where we've nicely aggregated a bunch of contract label names. So I'm going to say join on labels, and let's call this C, and we're going to alias this as trace, and we're going to join on where the blockchain is Ethereum, and where c.address is equal to the trace from, right? We're looking for the names of the contracts that are calling Seaport, right? So now I'm going to just do a coalesce of c.name versus from. So this should give us better names for things. And we're actually going to add one more filter, which is we don't want to include safes or contract wallets. So that means we don't want to include Gnosis or Argent as integrations because they aren't technically integrations. So the way I'm going to do this is I'm going to say and lower of c.name is not Gnosis, and the same thing here is not like Argent. Because this contracts table will tell you it's a Gnosis contract or an Argent contract, we don't want to include this. So let's run this again now. Cool, we can see that actually cleaned things up a lot. Like most of the other contracts are now gone now, because those are probably mostly like Argent wallets. If I look here, this was December 26th. Blur was 3,000 or so transactions. And then Uniswap Universal Router was 1,000 or so. Reservoir was 1,000 or so. Gems also 800-ish. And let's label our axes. So this is unique transactions. And X is just weeks. So this is useful, and you could make it a percentage to see market share wise what's been changing. So in this case, Reservoir gained a lot of share, but then lost it as well. But we can do better than this, all right? Because this is still including both modify and read functions. We only want modify functions in this case. So we're going to introduce another table, and this one is signatures. And I want this one, Ethereum signatures. So this essentially, if I just quickly show you what this table looks like. You can see it gives like some function signature or event signature, and then the name of that function as well as the ABI. So in this case, what I can do is I'll say left join from signatures. Let's call it sig function. So let's join this ID on the trace input, but we need to get just the first 4 bytes of it. So we're going to do substring 1 and the first 4 bytes. So now this would give us all of the ABIs, all right? But we need to filter for ABIs that are not of the view type. We don't care about view functions. What I'm going to do is I'm going to add to this where statement one more line where we're going to get the JSON value of ABI. And I want to take a strict match of state mutability. I'm going to take this value and I want to make sure that we're not getting view or pure function types. And in the case that a function signature is not matched by the join, I'm also going to say or sig function.id is null. So now this is going to give me only modify function calls. Cool. So you'll see this kind of changes our numbers a little, not by much, but it's good to just filter that out because you never know what noise you might get if you include the read data. However, and sometimes when you're looking at like Chainlink, for example, and you want to get like the price oracle calls, then you only want to look at the view functions, right? Or the view and pure functions. So this kind of works both ways, depending on what you want to filter for. Essentially now we've completed our task. This is basically the query we have here. The only thing I've done different here is I've made a parameter for the months, the number of months back you want to search in the data. I've added a parameter here for if you want to only be modify functions or not just be modify functions. And then there's also a few kind of chain parameters in here that work both at the table level and on a quoted level so that you can check this data on any of the chains in this dropdown. Hope you learned something cool. So for this week's bonus question, try and also attach ETH values to the integration type, right? So this should be pretty easy. If you watched week number 1, you understand how to get the ETH value transferred from a call. So you'll notice here, I'll give you another hint, that when Seaport is called, a value is attached with it. So can you figure out how to sum this count that we created to include ETH values instead? So best luck with that. If you figure it out, do DM me. And don't forget, submit and vote for what query you want to see next week into the link in the description. And I will see you soon.